Well, welcome. Today, we're going to be talking with a great innovation leader, Matt Greff, who I know through Lowe's Innovation Labs. Back in the day when I was at Wayfair, almost 10 years ago, actually, I got a chance to work with the Lowe's innovation team for the first time. We were working with technology called Google Tango, and I actually have my shirt on, Google Project
Nice.
Tango. Little shout out for that. But yeah, they were doing some cool stuff about, scanning and recording stores and then route planning, and we were doing kind of furniture visualization on the Wayfair side. Yeah, so Matt and I kind of go way back, and we thought this would be a great way to kick off a conversation. I'm planning on basically doing these hopefully weekly podcasts as a new series to highlight innovation across the industries. And I'm a co-founder and CTO at Super DNA 3D Lab. So want to help, kind of promote and talk about what we're doing. But Matt, let's hand it over to you. I'd love to, have
Yeah.
you give the audience a little background on what you've been up to the last few years.
Yeah. Thanks, Mike. Yeah, really excited to be here and kick off this series with you. So, yeah, I'm Matt Greff, formerly Senior Director of Product Management at Lowe's Innovation Labs. Prior to that, I had a lot of great industry experience running ad tech, Microsoft and Amazon, and just built up, huge affinity for data and how that benefits big customers and big clients. And part of my journey at Innovation Labs, just like you mentioned, Mike, is that trying to get things digitized from the physical world into the virtual world has gone on its own evolutionary steps. And throughout the years of trying to figure out photogrammetry, figure out implications on the real physical worlds, I came across some really amazing insights, both through data, but also through new concepts like a digital twin and some other things that I think has some amazing implications for the rest of the industry. So what we were able to accomplish with Innovation Labs in retail was amazing. But once you think about how this can impact other things like manufacturing and fulfillment and supply chain, the possibilities become endless.
Yeah, absolutely. And yeah, so the main topic of conversation today is kind of digital twin.
Yeah,
And maybe
love
for
it.
the audience, it would help to just do a quick, just short description of like what exactly is a digital twin. It's one of those terms that people have probably heard, but it's maybe they've heard it in different ways and it's been used in different contexts. So from,
Yeah.
your opinion, what's a digital twin?
Yeah, and as I describe digital twins to people, sometimes I'll hear answers like, "Is that an '80s rock star band, or is that some type of video game? Like, what's going on here?" And the concept is kind of like a video game. I just say, simply put, if you remember what SimCity was like, where you had this digital simulation of a physical city, kind of looking down from above. And the concept of a digital twin is really, can you take something physical in the real world and create a digital copy of it such that you could redesign it, you could simulate how it might look or act or behave in a virtual environment that everything simulates or replicates exactly what you do in the physical space. So if you think about it from like a store perspective, you could create a virtual store environment and you could try out different displays, you could try out different customer experiences. You could do all of this without having to move a single physical product or fixture or anything that the customer might see. And so the theory of it is we'll save a lot of time having to move things around physically. If I think about what your team's been doing with Super DNA, you guys have already been in the digital twin space. You've been creating digital copies of physical products for so long and allowing customers to interact with them virtually and using augmented reality. Hey, I want to see them in my space. I want to see what this chair is going to look like. That's effectively a digital twin of that product that you're about to buy. So when you think about it at a larger scale, the opportunity is to bring that to the next level with fuller scale digital twins, whether that's in a retail environment or a supply chain environment. But the real future of this is going to be in manufacturing, where you could virtually see a production line of a product as it's being assembled and all of the different robotic automation that goes into assembling that product. Imagine being able to simulate that in real time in a full digital copy, and you could run through thousands of iterations to make sure that your product is being optimized for production most efficiently without having that expensive downtime and the turnover time at every step along the way. So it's a really amazing technology coming out.
Yeah, when you think about that scale too of trying to do it, not just at an individual product level, but at a full, facility level. Well, one, it's a,
Yeah.
daunting to create all that content, which, we're here to help. But I think the bigger opportunity is that, the physical time it would take to move those things around to test out a scenario. You have to run it for probably a week or two just to get the data and
Yep.
then, make some adjustments. So it could take,
Yep.
months or years to get that optimal analysis that basically, Matt, you're saying we could do this digitally in, a matter of, probably hours of training simulation time, right? You
Right.
condense years of potential configurations and studies into minutes, and then you can
That's
analyze
correct.
data.
Yeah. Yeah, a simple way to think about it is, imagine you're, I mean, I came from a store environment, but let's imagine you're in a warehouse somewhere and you have a robot that you want to train to autonomously navigate around that warehouse. The way I see it, you have two options. One of them is you take the physical robot, you take it to the physical warehouse, and you move it, all the humans out of the way, and you say, okay, go run around and bump into things, and hopefully you don't cause too much damage as you learn how to run yourself around this physical environment. Or you could take a digital snapshot of that same exact environment, create a digital twin of it, have everything, the shelves, the boxes, even the people walking around, and then you can have it run through that training cycle thousands of times per hour. And it can collide with everything and knock over every shelf in the warehouse. I don't care. It's all digital.
Right.
But
Yeah,
all the
there's no
while, it can learn
yeah.
what to do, and then it can learn and show you, the human, what happens when the robot is going down an aisle and a forklift is coming or a human is in the way. What choices does it make to safely navigate in that environment? And so I would love to see a simulation of that happening thousands of times and all the possible permutations of it doing that, instead of putting that physical robot in that physical space and waiting, I don't know, however many months for it to run around and effectively, give
Yeah,
me
you're
the
trying to
same
find those
output.
edge cases, right? It's kind of similar with like self-driving car technology, right?
That's
There's a lot of
exactly.
simulations that happen. Companies like NVIDIA have built out tools that enable those kind of massive parallelized
Yeah.
environments to run. And then you can, basically conduct things in a condensed time scale and get the edge cases that are going to happen, one in
Yep.
a million miles. You might have some random car incident and without having to worry about endangering public safety or in this case like the safety of your employees, you can get a chance to run all those potential scenarios and then come up with ways
Yep.
to avoid it.
Yeah. So that's the hope and dream and promise of digital twin. But of course, if it was so easy, I think everyone would be doing it at this point. So, some of the challenges that I was seeing with that is really just how do you get the data together, everything from digitizing the physical space, but also when you simulate something with business operations involved, how do I get all of those? I'll just call them a two-dimensional database of information, whether that's a sales performance report or a production throughput report. All of that is effectively linear if you think about how the data is structured and stored. None of it is set up to effectively map to something in 3D. So the original architects of these systems were never thinking, oh, I need to make sure that my data is compatible with this 3D environment. And so that's really the big barrier that, if different teams can figure out how to overcome that, it will mean a significant advantage with all those benefits we just talked about. But the biggest holdback is that initial investment in, okay, well, how do we transform a decades old style of data capture into a new kind of three-dimensional virtual space? So I see
Yeah,
that as one
it
big
kind of, a
challenge.
lot of it starts with the 3D model, which is kind of what our team's been doing for years on the product consumer facing side.
Yep.
And we've seen the evolution of 3D models and the representation and the ability of those models to be more complex evolve over time. Like one of the roles I have is with the 3D commerce group, that's a group within Kronos. Kronos promotes standards, including GLTF, and we've been working on new extensions, including interactivity is one that's kind of
Yeah.
undergoing like rapid development and will
Yeah.
be publicly available soon. So being able to extend the 3D model to beyond just like a static representation, but to something that has different interactions or animations or rules defined with that model, allow you then to plug it into a system that's more complex so they can
Yeah,
now start to communicate with each other.
that's
And so I
right.
think we're going to continue to see advances on the model representation side that'll help unlock, these bigger, more complex scenarios.
That's right.
Uh, but yeah, you still have to, I guess, take the time to invest in 3D content to begin with so that you can, effectively simulate the interactions. And one thing I'll just mention on the 3D content side, because I feel like it's a common misconception, especially in these manufacturing industries where you have a lot of CAD data. You don't necessarily need the CAD data to represent the 3D model. In fact, there's usually a conversion process that has to
Hmm.
happen from manufacturing CAD into product representation. And I imagine you guys ran into that a lot at Lowe's. I know you had a
Yeah,
3D scanning lab, for example. So
yeah,
rather than, take a CAD file that you might not even have access to
right.
create a 3D model, like what do you typically find that process is like?
Yeah, that's great. I mean, historically speaking, when I first met this problem a little over 5 years ago, it exactly as you described. There was some, we'll call them product vendors, but some basically manufacturers that had a CAD file, but it had no exterior to it, had no materials. It was just the skeleton or the blueprint of the file. In some cases, the exact manufacturing details, which is great for when you're trying to figure out how to build a product, but horrible for when you're trying to figure out how to market the product. And
Yeah,
so even when we'd have the exact down to the millimeter blueprint, how does it look in real life with all the materials, the reflections, the textures, and then even when we would try to say, okay, the other option would be to do photogrammetry. So how do we invent a system where the vision is I receive a product, I can put it on a table or a plate, I can spin that around and capture it and then run it through photogrammetry. That was still very time intensive. You had to receive the product sample, you had to do the photogrammetry itself, you had to run it through multiple processes, and then the output still required a human artist to come in and touch something up. And so the cost, it was still cost prohibitive from that perspective. So recently, with a lot of the advancements in artificial intelligence, we found out ways that you could just take simple, 3 or 4 picture photo reference, run it through an artificial intelligence process to not only give that 3D underlying 3D model, but also that the materials and what does the outside of the product effectively look like. That's still, I'd say, probably tackling 10% of the problem, even though it gives you 90% of the benefit for how it moves physically or how it looks physically. Kind of back to the point that you were mentioning earlier, it's still missing the rest of the, well, how does the product actually perform?
yeah.
So if you,
What's the
what does
axis
it
of
move? What
and
happens when
plot?
you,
Yeah,
yeah, I was thinking a lot about, at home improvement, I was thinking a lot about appliances. So what happens when you open the doors to the refrigerator or when you use the power tool, what sort of torque can it output and how does that, change the building process? And so we're really only describing, the shape and the look of a product, but not how does it perform, how does it work, how does it operate or fit with another product. And I absolutely see that as the next wave. So I'm really excited, for the work that you're doing with Kronos and the GLTF standard to add more of that metadata and those physical attributes to different products that will kind of enable them to operate in a digital twin, kind of a future digital twin world, with all of those same physical attributes that we just natively understand, just by interacting with objects around us in real life. So I see the huge potential for a lot of that advancement, not only with products, but also when you start thinking about physical space. So how do we go and apply that same process to physical space? It's going through the exact same evolutionary curve. So in the beginning, you start with, hey, can I get the blueprints for this facility? It's exactly like a CAD drawing, but it doesn't really show you the materials or what something looked like. You still have to figure out the textures and
because
the
someone's
placements of things,
maybe
and
manually going in and doing that,
it's
and
it,
maybe
yeah,
3D scanning that we've seen, can help.
Exactly.
But typically, a lot of what I've seen in the past with like a laser scan in a facility, it gives you great reference data, but it's not very usable. It's
It's not
typically
very
dense,
useful.
heavy.
Yeah.
There's like millions of little points. You
Yeah.
get little pieces of stuff that you don't want, and then
Yep.
you have to basically go in and optimize everything.
Yep.
Especially when you think about people running these in, let's say a web-based application. It's maybe on their mobile phone, on a tablet, maybe it's on a headset. But these types of experiences have to be performant and lightweight enough
That's right.
that you can download it quickly,
Yep.
get the data you need, have it run on the device without killing the battery,
That's right.
and at the end of the day, have it look representative of what the actual product is, at least close
Yeah.
enough.
Yeah, that's exactly right. And so, we have that opportunity now in the industry, so you can, take a video or even just photo reference of a physical facility, and then AI can assist in filling in the rest of those details. And even if you come up with a very complex, let's call it 1.5 million foot warehouse in these very, very large, complex spaces, it's also fascinating to me the parallels with the video game industry, because you can also build in almost like a video game like environment. I mean, we're still using Unreal Engine and Unity, and NVIDIA Omniverse, to help kind of hold these environments in digital space. And so you can benefit from the exact same streaming technologies and cloud rendering technologies. So if you want to look at it on a form factor like your phone, or a tablet, the tablet itself doesn't need to be the most powerful GPU in the world to run this environment. It just needs to
Yeah,
be able to
like
tell
with
the
data.
cloud where I'm at, what I'm looking at, and my general kind of orientation, and then it can fill in the rest of the gaps for you, as well as pulling in a lot of the data elements. And so the future of this is really going to be architected around being able to get different business data aligned to that virtual 3D space, and then having an intelligent cloud system that can feed and kind of stream that to a user or to an autonomous robot that's trying to also interpret the world around it in digital space, and feed it on a just-in-time basis. So it doesn't have to always hold everything in memory. It just says, hey, I've got this specific task, or this human is, I have this specific question, analyze it for me, and then feedback the answers, or the suggestions for how I might be able to go solve for this.
Yeah. Yeah, it's interesting, and you can, on the human side of it, you can also think of the training, opportunities there too, which
Yeah,
kinda relates to the gaming aspect of it,
that's
right? You
right.
can
Yeah,
on different scenarios, or, maybe it's a warehouse that's on the other side of the world that you need someone who's an expert to kinda tour and inspect or give some feedback. You can,
yeah,
kinda bring that in digitally, and, as we think
yeah,
about, let's say, like the medium to longer term future, when you have AR and VR technology that kind of like interplay with each other, you can start bringing people together, both physically and virtually,
and virtually. Yeah,
in space, which could be pretty fascinating for
yeah.
even just conferences and meetings and everything.
Yeah. Imagine if I took you on a virtual factory walk. I was super proud of the automation that we just installed. You're halfway around the world, and I want to be able to show you what we did, how it's operating physically. And while I'm giving you that virtual factory walk, you can see the overlay of all the real time stats for how everything's performing, in
Yeah,
the
actually,
same view.
that's one other topic I wanted to hit on before we
Yeah,
conclude. We're getting close to time, but I'd like to talk about maybe again a little more late term future, maybe 5 to 10 years out. But the sensor data that's
that's right.
available, a lot of these pieces of equipment, that could be connected to the digital product, right? And usually
Absolutely.
but digital twin, like that's kind of the complete version of it. It's so you get the full control. You can maybe control the product digitally, and you can also get the sensor data back digitally to see how it's performing, analyze it. You get the engine temperature, RPMs,
Yep.
or whatever it is
Yep.
for any given product. And you could see that overlay on the physical thing with the digital information. Do you want to talk a little bit about how you see that evolving?
Yeah, well, I mean, it already is. So there's a lot of what's happening right now with sensor data, and usually, and what I mean by that is you can look at, you mentioned a few of those, like temperature sensor or throughput sensors. A lot of the things in manufacturing have some form of a digital input and output already. So those things are largely set. In retail, you think about sensors in the forms of cameras, in the forms of RFID tags, or even Bluetooth tags on devices and things like that. All of this data is being captured natively in individual applications, But what we're describing is how do you pull that together so that the data itself not only represents locally what that specific object or person or thing is doing, but then also semi globally to kind of understand how is this ecosystem or how is everything kind of flowing at a more macro scale. Once you get there, you can start applying intelligence or algorithms, honestly both, that will help you synthesize a new set of data that you could never unlock before. So in the retail setting, if I understood where the humans were running in the store, okay, that's interesting. It helps me optimize for merchandising, for different categories, for different shopping experiences. But then it also helps me understand, well, if they're lingering, if they're looking and kind of dwelling in a certain area, or if there's certain products that are maybe getting looked at but not purchased. Those are things that gives me visibility into a metric that I could never see before, or an AI could never see before in an optimization loop. So it's sort of like, where can we apply sensors that bring light almost to an organism? Like, how do we see light for the first time that helps, whether it's a digital twin or an AI agent kind of operating in that digital environment, to be able to synthesize or to predict something that before was unseen. So when we're thinking about a factory, it's okay. I can digitize my production line. I can see how the products are flowing and all the metrics that align with that. But then from the sensor perspective, you also get that zoomed out view of, well, now what happens if we change it? What are going to be the required inputs, the required changes to simulate something different? And then what new sensors or what shift in the production line are going to be required? Um, it also
Yeah,
enables, a
feels
future
like it
potential.
helps, validate some of the training simulation data as well,
Yeah,
right? So, a lot of times in simulations, it's kind of you to assume that it's gonna work 100% of the time, or you
yeah.
assume that the physics
Just
are gonna
assume it goes according to plan, of course. Yeah,
exactly. Yeah, everything goes according to plan, right? So if you can bring in that sensor data from the real world
yeah,
and start seeing like where
yeah,
are those like disconnects
yeah.
happening, especially when you have like a much larger both time period and just amount of inputs and data from every single piece of equipment, you get that whole orchestra coming together. It's no longer just one.
Absolutely.
You're
One individual piece or
failure
component.
happened
That's right.
here. If you could zoom back out, maybe you realize like, oh, we're overburdening this one because we get two different assembly lines that are taxing it. And if we were, to change this or adjust the time, now this one would have the chance to, cool off and or whatever, right? So there's
That's
like
right.
different scenarios that you can envision that data helps bring to life over time.
Yeah, that's exactly right. And so, yeah, once you get this set up, it enables, and potentially it could enable a completely different production flow. If you think about things like PCB manufacturing, it's not necessarily linear. When you're running that circuit board, it might go through different heat treats or different, copper stamping, and it's described to me like building a Big Mac, but it's like custom order for each client that comes in. So you don't know how that sandwich is going to be made. And so it might go through completely different setups and back and forth multiple times. And up to date, it's required humans to kind of figure out based on a set of instructions. Okay, where does this go after this one piece of process is done? In the future, with the combination of sensor data, like you mentioned, but also kind of deeper understanding of how the product itself needs to be manufactured, you could have a digital twin guide a lot of that production process based on where each individual product sits in its own individual manufacturing step, not the factory's linear manufacturing process. And so when you think about nonlinear production, digital twin has an amazing opportunity to go with that. And the way that I see electronic and different, robotic and different manufacturing capabilities going in the future, it's just it must rely on something like this. Otherwise, the complexities will just be far too great for any human or team of humans to figure out, without just drawing out a lot of time.
Cool. Yeah, I think that's awesome. We're getting close to time, so I'm gonna just kind of wrap it up and give you a chance to just kind of
Sure.
plug any other topics or thoughts that you wanted to hit on today. And and then we'll let people get on with their day.
Awesome. Thanks, Mike. Yeah, I think there's the big takeaway that I tell my teams and a lot of people in industry that I meet around kind of the concept of digital twin is giving getting visibility to a digital twin is one thing. So being able to see that physical environment, to be able to operate and kind of move around the physical environment like a video game, and the interactions that come with that. It's not too difficult to see how the next generation of, I'll just say, kids growing up playing Fortnite and playing a lot of these video games, they're just going to be native to that type of environment. And so, to be placed back into a physical space and someone has to manually walk them around and hand them a piece of paper to figure out how to do their job, it's going to be just as foreign to them as it is for us, older generation folks to be thinking about, artificial intelligence and some of the new things coming. So,
Yeah.
I
Or even
say, step
right?
one.
Keep your check ledger or something like back,
Yeah,
as a kid, you get exposed to, the old way of doing things, and then you see the new way. And I
yeah,
think you're right. This is one of those things we're in the transition phase,
we are
and it's
absolutely.
exciting for all of us to kind of see where it takes us.
Yeah, that's right. So, once you think about, okay, I've digitized my space, and now that helps me enable simulations, which is something that still today requires a lot of, whether it's video gameplay engineers or, really skilled analysts to be able to construct a simulation. The thing that's going to come next in the future is with AI is a much quicker ability to ask a question. So imagine being able to ask a question of the digital twin. Hey, what would be the most optimal way to achieve X? And then the digital twin with that AI intelligence ability can simulate it and show you what that's going to look like. So I'm trying to get that vision for folks to understand of, imagine like a GPT interface where I'm asking questions of my warehouse, and then it's showing me different simulated outcome potentials and guiding me through a decision making process to select one of those. So I think it's the combination of, it's not just digital twin alone, but it's also what can digital twin plus artificial intelligence do to
Yeah, how
really
does that
transform the way
translate
that I'm
to
doing
human
this.
productivity too? I think, it's always
Yeah,
worth mentioning as we talk about these technologies, especially AI, because we're in this early, phase where I think there's still a little hesitation to, is this gonna, completely replace jobs? Do we not need humans anymore? And I think, what I believe, and I believe, you as
yeah,
well, is that this is a tool, it's an augmentation, it's gonna
sure.
make people more efficient and productive. It's not going to necessarily pull them out of the equation. It's just like we've seen over the last, century of innovation. As factories get more productive, we
Yeah,
end up working more, not less. So I think,
yeah,
it's in some ways a little scary because it's unknown, but at the same time, if you just think of it as a enhanced tool in your tool belt, to basically make content faster, cheaper, better, then we all win in the end.
that's right. Yeah, you got to keep moving forward. I always, the thing I'll end with is, go back to the start of the computer age itself. Well, even the name computer came from, originally, that was a human job. To be a quote unquote computer was to sit at a desk and crunch numbers all day on, very old, primitive calculating machines. And their job was to compute stats for accounting or for business and things like that. Then along comes the electronic computer that, yes, it replaced a lot of those jobs, but the people that were previously working in those jobs took up other functions. And plenty of people are still employed today because of computers. The next thing
Yeah.
is going to happen with artificial intelligence. It's not going to replace my job. It's just going to replace what I have to do on the
It'll
job.
take
And
out
then
the
it'll and
tasks
then
that are a little bit, less enjoyable, so you can
That's
focus more on
right.
the creativity and the interesting
Yeah,
aspects you do.
absolutely. So I'm really excited for that future, just as much as I think digital twins will have a massive impact on it.
Excellent. Well, I want to thank you, Matt, for joining us on our, newly launched podcast series.
Love
Still
it.
yet to be titled, but yeah, it was a great conversation. And if you're watching, let us know in the comments how you enjoyed it,
Yeah,
and what else you'd like to hear us talking about on future episodes. So,
that'd be
thanks.
great.